Okay, we have come to vector fields, our last topic. So here we are in question 1 and 2, just being simply asked to evaluate a few particular points within the vector field. So what we're doing, again, with vector fields, you could take any point in the graph and make it the starting point of a vector. When you do that, it's like, for instance, 1, 0. Let me make this that color. So 1, 0 right here, that's the start right there of a vector. Now we need to know what direction and how far to point that arrow. And how we do that, we're going to say we start at 1, 0, and the vector itself is going to have a magnitude in the x and the y by evaluating this. The x term of the vector takes the y term of the original, so 0 squared. So 0. The y component of the vector is found by taking the original point's x term and squaring it. So 1 squared. What this gives you is the direction of start at 1, 0, which we did, and then from there, the vector points 0, 1. So we go 0, 1, which means our point is right here, and that's our vector. It's very, very short. Now, if you were to add those components, think of it as like this is one vector and another, and we want to add them, we would get 1 plus 0 is 1. 0 plus 1, also 1. And what this column will give us as we do more of these, that gives us the ending point. So this is like the initial point, 1, 0, and this is the ending point. How did we get there is this middle column. So let's do another point, 2, 2. So we're going to evaluate the vector and say the vector itself, it starts at 2, 2. Where does it go? Well, it goes over in the x direction by taking the y term squared. So 4. And the y component of our vector takes the x term squared, which also happens before. But again, that is from 2, 2. So where's over 2 up 2? That's right here. From there, we go over 4 to the right and up 4. So 1, 2, 3, 4, 1, 2, 3, 4. And we make our vector. Now, if you were to add those two components together, 2 and 4 is 6, 6. So let's check. Well, there's our 6 and our 6. So everything checks out. We're good to go. So, and I apologize, I meant to do this last time too. Let's change the color so we're turquoise. Let's move on to this next point. -2, 1. Finally, two pretty different numbers. So our vector is going to be evaluated. So let's take the x component of our vector is going to be the original y squared. So that's just 1. We take our y component of the vector is taking the original x and squaring it. So -2 squared is 4. Well, let's see. So -2, 1. There we go. From there, we're going to go to the right 1 and up 4. 1, 2, 3, 4. There's our vector. Let's check it out. -2 plus 1 is -1. And 1 plus 4 is 5. Did that check? Yes, it did. There you go. There's your point. And okay, let me pause just to help with time here. I'm going to pause and do the other two, and then we'll just discuss them. Okay, boom. There you go. There's our last two. So the last two vectors, everything was the same. I just wanted to save some time in the video. So 0, 2 got applied to the vector function. So our x take our 0 squared. Nope, or 2 squared, sorry. 2 squared, we got 4 for the x component. The y component took x squared, which was 0 squared, which still means 0. So from 0, 2, we go over 4 and end. when you add those two vectors 0, 2 and 4, 0, you get the 4, 2 as our endpoint. And there it is on the map. Same thing, last one, -2, -2, and you're going to take y squared, x squared. So they both become 4, 4, and you add -2, -2 to 4, 4, you get 2, 2, and that's what the map looks like there. So that is the function 1. This one here isn't going to be a whole lot different. In fact, the process is exactly the same. The points we have are a little bit different from question 1, but the bigger thing is, the x term is still going to be x. They're using this bracket, almost like a component form bracket, instead of parentheses. That does not change anything about it. I don't know why they changed the format of the parentheses. Let's do 1, okay? So I'll start with our orange again. So we started at the point 0, 0, and we apply the vector form. So the x of the vector is still the x from the original, so that's still 0. The y component, you're going to take e to the y. Well, we haven't talked about exponential forms and taking the number e, yes, the number e, raised to 0, but anything raised to the 0 is just 1, right? So 0, 1 is the vector. So when you look at that, 0, 0 becomes like 0 plus 0 and 0 plus 1. So we start at the origin, and we go over 0, up 1. So again, it looks something like that. I know it's very, very small. There it is. Now, moving on to our next one. Okay, we got our changed color. So here we got 1, 1. So when we go to evaluate that in the vector function, our new x is the old x, because that's what it says to do. Our new y is taking e to the y. Again, e to the y. We haven't talked about e, but e to the 1. So I'm just going to write that at least at this point. I'm just going to call it e to the 1. Now, the ending point, so we're going to add the two components. What we find is our ending point is 1 plus 1 or 2 for the x, and 1 plus e to the 1, or 1 plus 2.718 is 3.718. So 1, 1 is our starting point. There we go. And we're going to go over 1, up 1, 2.7, somewhere like that. And there you have your vector there. So what I'm going to do now, rather than walk you through every one of them, I'm going to pause it. I'm going to fill in the rest of those, and then we'll just kind of highlight the rest of those. So bear with me here as I pause, and we'll get caught up. All right, there you go. So our last couple of problems here, as you can see, there's really no difference in the process, but the numbers just change. So for example, our next question we were going to do is -2, 2. So we start our origin, the initial point of the vector, at -2 up 2. From there, we applied the vector x, e to the y. X is just x, so that's still a -2, and y is e squared, e to the second power here. When you do, e squared is like 7.39, whatever. So you add 2 to that. So from -2, 2 here at the origin, you went another -2 up 7, or sorry, yeah, up 7.8, 7.3. Next, we had 0, 2. That was this point here. And from 0, 2, the x remains the same. And the 2 is another e squared. So from 0, 2, which is right here on the y-axis, we went over 0 again, and we went up e squared, which is up 7.39 for a total of 9.39. So that's your ending point there. And our last one was -2, 2. So again, the x of the vector is the same as the x originally. So the initial point, -2, 2 down here, we go to the left to -2 more, and then e to the -2 is like well, it's 1 over 7.39, what have you. So it's about 1.3 or 0.3. So negative 2 plus e to the negative 2 gets you about negative 1.86 for a final point. So your vector looks like this. So that, again, combined, questions 1 and 2 is a great way to understand evaluating vector fields. And our next video here, we will work on matching vector fields to their graphs. So there it is. Thanks for listening, and we'll see you in the next video.